Hi everyone, I am Jessica Foster. I am the plant agronomist for the Plant Tissue Analysis Lab at the North Carolina Department of Agriculture and Consumer Services Agronomic Division. For this session, I would like to discuss fertility monitoring and petiole sampling of strawberries. This topic will include what a plant tissue analysis is and the importance of tissue sampling and petiole sampling when it comes to strawberry management. We will also highlight common nutrient deficiencies found in strawberry plants and pull example reports to look at these deficiencies and how to take corrective action. So what exactly is a plant tissue analysis? A plant tissue analysis measures the concentrations of nutrients in the plant leaves and compares them to research sufficiency ranges. So how does this process begin? It begins when a grower goes out into his field and collects a representative leaf tissue sample for the crop he is working with. This is demonstrated in the picture at the top. The package is then submitted to an agricultural lab, and the lab then dries and grinds the leaf tissue as shown in the bottom picture. Once the tissue is ground, it is then measured for the concentration of the essential plant nutrients. Now the nutrients measured will vary by lab and by grower request, but most labs measure for nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur, and one or more micronutrients, which are usually iron, manganese, zinc, copper, and boron. A sound fertility management program should include both soil testing and plant tissue testing. The soil test tells you the level of nutrients present in the soil relative to what the crop needs for the upcoming growing season. The tissue test tells you how much of each nutrient the plant takes up relative to what the crop needs. The plant tissue testing is not a substitute for the soil testing and vice versa. They are meant to be complementary. In addition, the tissue test provides some information that the soil test does not. Nitrogen is not measured on the soil test report in most states. It is assumed to be 0, and recommendations are given for how much N is needed for the upcoming growing season. Boron is also not found on soil reports and is measured in the tissue testing. This makes the tissue testing useful because it includes these nutrients. There are several other advantages of plant tissue analysis. Routine tests are widely used in high-value crops such as strawberries. With strawberries being such a high-value crop and being maximized for yield, the fertility is tightly managed. Routine tissue sampling is done on this crop more so than other crops so that fine-tuning of the fertility program can occur. The tracking of fertility needs begins with bloom and continues with sampling occurring every other week. Tissue analysis is also used to troubleshoot suspected fertility problems when plants are showing an abnormal growth habit or color. Tissue tests are frequently used to distinguish between fertility problems and other problems. Environmental conditions such as excessive wet, dry, or cold soil can inhibit nutrient uptake and create deficiency symptoms, even when the soil fertility levels are adequate. Scenarios where plant tissue nutrient levels are low, but soil nutrient levels are not, suggest that environmental factors are driving the abnormal symptoms and that fertilizer application would not be recommended. In addition, it is often difficult to differentiate between fertility problems and pests or disease. Scenarios where plant tissue nutrient levels are adequate, but the plants are showing abnormal symptoms usually indicate that a disease or pest is the source of the problem. Excessive nutrients can have negative effects on crop growth and productivity. While macronutrients don't really cause true toxicity when supplied in excess, nutrients like nitrogen can cause a myriad of other problems when over-applied. Excess N makes plant more disease-prone and can impact fruit flavor and set. Additionally, excessive uptake of one nutrient can inhibit uptake or assimilation of other nutrients. This process is termed antagonism, and nutrient ratios are frequently included on plant tissue tests in order to evaluate nutrient balances. For example, N can inhibit sulfur. Boron toxicity is the most commonly observed toxicity in North Carolina. A tissue test can be used to determine if abnormal symptoms are due to toxicity rather than deficiency. Before we dive deeper into how to interpret a plant tissue report for strawberries, I want to take a moment to explain what the tissue test shows and what are the principles behind the interpretation. A plant tissue analysis report will show the concentrations of the nutrients that were measured in the leaves. Here is an example of a strawberry report that was run at the NCDA lab. As you can see, the macronutrients, which are listed as percentages, and the micronutrients, which are listed in parts per million, are found at the top of this page. However, the concentrations alone are not useful to the grower without a means of interpretation. On the next slide, we will go through how to interpret a tissue report. So what exactly does the interpretation index show us? The standard practice for tissue analysis interpretation is to compare the measured concentrations to a sufficiency range that is based on effects on crop growth or yields. This system established the critical concentration of each nutrient for each individual crop and is the product of decades of agricultural research. NCDA alone has interpreted sufficiency ranges for over 600 different crops. In the hypothetical response curve shown below, you can see that nutrient concentrations are considered deficient when they produce growth or yield that is around 50% or less of the maximum growth or yield. A concentration is considered low if it produces growth or yield that is around 50 to 95% of the maximum. This area of the response curve is called the hidden hunger area. At nutrient concentrations in this range, the plant is likely not showing outward deficiency symptoms, but is still experiencing reduced growth or yield. The green part of the curve is the sufficiency range. Concentrations in this area are considered optimum for growth or yield. Concentrations in excess of this range are considered high or excessive and indicate over-fertilization. As we have already discussed, excessive nutrients can cause a number of problems to plant health and productivity, and concentrations in this range indicate if these problems will manifest. Below is a plant tissue report with the crop being strawberry. As you can see, each nutrient contains a numerical index along with a letter index. The NCDA reports both the numeric and the letter index, with the lettering being, as we discussed before, D deficient, L low, S sufficient, H high, and E excessive. The tissue sufficiency ranges used by the North Carolina Department of Agriculture and Consumer Services for strawberry are from the Campbell and Minor reference, and the concentrations of the essential nutrients are based on the most recent mature trifoliate leaf. That is the leaf that is circled in the diagram below and what should be collected when sampling for strawberries. Now let's go over petiole nitrate sampling in the strawberry. In addition to the standard leaf sufficiency ranges, strawberry management in the Southeast also includes analysis of nitrate nitrogen in the petiole. Petiole collection is a critical component of strawberry tissue sampling, especially when biweekly sampling occurs. Petiole nitrate analysis is able to provide a direct reflection of nitrate uptake on the day of collection. This information allows producers to fine-tune the nitrogen application to maximize yield and quality and to extend the fruiting season. When collecting petiole samples, there are a few things to keep in mind. You need to make sure to avoid collecting during cloudy or wet weather, as this can affect the nutrient levels. Also remember that the petiole nitrate nitrogen will vary based on the stage of growth of the plant and whether that is the bloom or fruiting stage. What are the petiole nitrate nitrogen ranges for bloom and fruit? Presented here are the low-end and high-end petiole ranges for bloom and fruit stages of growth. Each week corresponds to a specific concentration range. Petiole sampling begins the first week of bloom, which is characterized by the presence of 5 to 10 open blossoms on at least 50% of the plant, or said another way, it means strawberries will be ready to pick in 4.5 to 5 weeks. The first week of fruiting should be approximately week 4. This is what is circled here. However, this does not mean that you start your weeks over at week 1. Fruiting does not equal week 1 again. Fruiting equals week 4, and then you continue on with your weeks at 5, 6, etc. What do we do if these ranges are not where they should be? Well, for corrective action, if the nitrate concentration is low, the recommendation is 7 pounds of nitrogen an acre a week. If the nitrate concentration is within range, then the recommendation is to give a maintenance rate, which is 5.25 pounds of nitrogen an acre a week. However, these recommendations are not set in stone, and that growers need to know that they can be altered if they are in different locations around the state. If they are in areas, especially in areas with sandy soil, they are prone to leaching of nutrients. And if you need to alter this rate and add more, that is okay. Now let's go over some examples of how labeling correctly with the bloom and fruit stage and also the week is important. These next 2 slides show examples of tissue reports and proper labeling. The first example is labeled as growth stage fruiting and week 4 since first bloom. Based on the chart in the previous slide, week 4 nitrate concentrations should fall between 2,000 and 4,000. This example has a nitrate concentration around 2,800, falling within the range for the week indicated on the sample. In example 2, the growth stage is fruiting, but the week is reported as week 1 rather than week 4 or 5 since first bloom. The week 1 nitrate target is less than 500 parts per million, whereas it is 2,000 to 4,000 parts per million for week 4. Reporting the week incorrectly as the week 1 makes the interpretation that the nitrate is much higher than needed rather than on target. This last example has a growth stage of fruiting, but no week associated with it. The nitrate value is around 2,300, suggesting the week could be anywhere from week 4 to week 10. By not reporting the week since first bloom or reporting it incorrectly, the grower will not receive the correct nitrogen interpretation for that week. It is in the interest of the grower or agent to document the time of first bloom and to report the subsequent sampling weeks accurately. This example plant information form shows where to report the growth stage, bloom and fruit, and the corresponding week. When submitting the petioles, they are considered part of the same sample. They should be bagged separately, but labeled with the same sample ID as the most recent mature leaf that they were detached from. Many labs in the Mid-Atlantic region analyze strawberry samples. NCDA accepts out-of-state tissue samples at a 1 to 2 day turnaround time from receipt. We will now switch gears and cover some of the most common nutrient deficiencies found in strawberry plants. This chart here shows 11 nutrients and the corresponding percentage of samples that were found to be below the sufficiency level in the tissue. This was based on approximately 2,000 samples submitted to the NCDA lab between the years of 2017 and 2020. We will now take a closer look at 4 nutrients that had the highest percentage rating that were below sufficiency. These nutrients that we will look at are nitrogen, which was below sufficiency at 34%, magnesium, below sufficiency at 10%, sulfur, below sufficiency at 13%, and boron at 7%. We will also cover the nitrogen to sulfur ratio and what it means and why it is important in strawberry monitoring. Let's look at nitrogen deficiency in strawberry. Nitrogen is constantly monitored in strawberry production. Over-fertilization leads to soft fruit and reduced yields, and under-fertilization leads to poor growth and reduced yields. The picture on the top right shows the early stages of nitrogen deficiency, with chlorosis occurring on the older leaves. The picture on the bottom right shows more advanced stages of nitrogen deficiency, with the older leaves taking on a reddish appearance. The next two slides walk through examples of nitrogen deficiency in the leaf tissue, or the petiole, or both, and what corrective action can be applied. Now we will go over some nitrogen reports. In the first example, the report is shown with sufficient tissue nitrogen, which is at a sufficient index of 54, but a high petiole nitrogen based on the stage of growth and week indicated. The stage of growth was fruiting and the week was 5, and the NO3 level was at 4020. When petiole nitrogen is high, additional N may not be needed this week. You can still consider the rate of N you have already applied. However, too much N can lead to vegetative growth and soft fruit. Moving on to the bottom example, example 2, they both have a low tissue N and a low nitrate reading. The tissue N has an index of 47 and the NO3 reading is 1,330. Remember that the petiole nitrogen is a more sensitive indicator of evolving real-time nitrogen needs and enables fine-tuning of nitrogen application. The leaf nitrogen is indicative of long-term historical N status. So in this example, we would recommend that you increase your nitrogen rate by 1 to 1.5 pounds of nitrogen an acre a week and sample again in 2 weeks. This last sample shows leaf tissue N is low, as indicated by the red box with an index value of 44, and the petiole nitrate is sufficient, as you can see highlighted in the green box at 1,960. When this occurs, you can stay at the maintenance rate of 5.25 pounds of nitrogen an acre a week, or your current rate, and sample again in 2 weeks. The next nutrient deficiency we will cover is magnesium. So how is magnesium deficiency presented in strawberries? Well, the first early symptoms of magnesium deficiency are interveinal yellowing in the older leaves, as shown in the picture on the right. A more advanced stage of magnesium deficiency is shown in the picture on the far right, with necrotic spotting around the edges of the leaves. Magnesium deficiency may occur in sandy soil, acidic soil, or during cold, wet periods. So what is the corrective action for a magnesium deficiency? The corrective action is a one-time injection of Epsom salts at 10 pounds an acre per week. When we take a look at the report at the bottom of the page, we can see that magnesium has a deficiency index of 24. So what would we do as a corrective action? We would apply the corrective action of Epsom salts, and we would continue to monitor the magnesium level by sampling at least every 2 weeks. The next nutrient we will cover is sulfur. Sulfur deficiency presents as uniform yellowing in young leaves. Shown in the picture on the right is a control leaf where no sulfur deficiency is present, and the deficient symptoms are yellowing. This deficiency may occur in acidic soil, sandy soil, and waterlogged soils, or where the nitrogen to sulfur ratio is high. As you can see with the report at the bottom of the screen, the sulfur has an index of 35, which is low. So the corrective action here would be to use Epsom salts as a rate of 7 pounds an acre. If magnesium and sulfur happen to be low together, Epsom salts can be applied to kill 2 birds with 1 stone. Now we will switch gears and talk about the nitrogen to sulfur ratio. In addition to the nutrient levels in the leaf and petiole, an important part of fertility management in the strawberry is monitoring the nitrogen to sulfur ratio. Strawberries are sensitive to the nitrogen to sulfur ratio relative to other crops. When this value exceeds 18, this indicates that there is not enough sulfur for the crop to fully utilize nitrogen. The recommendation is to feed 1 to 2 pounds of sulfur an acre using a soluble sulfur source, Epsom salts, to balance the ratio. The next 2 slides will look at examples of the nitrogen to sulfur ratio and the corrective actions that can be taken. Now we will go over some example strawberry reports that look at the nitrogen to sulfur ratio. The first example shows that nitrogen and sulfur are sufficient. As you can see, nitrogen has an index of 67 and sulfur has an index of 52. However, the nitrogen to sulfur ratio is high at 23 to 1. This situation can occur, and the correction is to apply 1 to 2 pounds of sulfur an acre to balance the nitrogen to sulfur ratio. If Epsom salts are used, which is 14% sulfur, 7 to 14 pounds per acre will supply the 1 to 2 pounds of sulfur that is needed. You will continue to submit tissue samples every couple of weeks to monitor the response. The next example shows a low sulfur index, which is at an index of 42, with a sufficient nitrogen level at an index of 51 and a high NS ratio at 25 to 1. With sulfur being low, this leads to poor utilization of nitrogen and sulfur. The corrective action is the same as mentioned previously. You will still continue to monitor and sample as needed. This last example shows low nitrogen at an index of 44 and sulfur, which is also low, at an index of 39, and the NS ratio is high at 23.4 to 1. The corrective action for this scenario is to increase both nitrogen and sulfur and resample every 2 weeks to monitor the nutrient levels. The last nutrient we will cover in detail is boron. So how do boron deficiency symptoms first appear in strawberries? Boron deficiency first appears as leaf tip burn around the edges of the leaves as shown in the picture on the top right. As boron deficiency advances, this can lead to poor fruit set and small, soft, deformed fruit as shown by the deformed berries in the picture on the bottom right. Boron is highly leachable, and boron deficiency may occur in sandy soil and cold, wet weather. As you can see in the report below, boron is deficient at an index of 22. So what is the corrective action? The corrective action is to apply 0.125 pounds of boron an acre and to get this application in before fruiting occurs. Boron is very important for flower production. However, when applying boron, the line between sufficiency and toxicity is narrow, so be careful when applying this application. So what do we do if boron toxicity shows up in strawberry plants? Boron toxicity appears as bronzing of the leaf as shown in the picture on the right. The picture on the far right shows necrotic spotting around the edges of the leaf, which is a more advanced symptom of boron toxicity. The recommended boron sufficiency is between 30 and 50 parts per million. The boron level indicated in the report below is at 500 parts per million with an index level of excessive, which is roughly 10 times the sufficiency range. Boron becomes toxic around concentrations of 200 parts per million. If this occurs, stop pushing boron and keep tissue sampling to track the boron concentrations. The last topic we will cover is how to proper tissue sample for strawberry tissue. Most strawberry samples are submitted as monitoring and predictive samples. These samples are collected bi-weekly from early bloom through harvest, which starts about March 1st. This is also the bloom and fruit growth stages. If a diagnostic sample is needed during the strawberry season, collect this sample as soon as abnormal plant growth or color is noted. The most recent mature trifoliate leaf is what is collected. The most recent mature leaf isn't the mature leaves laying down on the plastic, and it's not the one in the middle of the crown, but in between these positions. It is full-sized and dark green. It is healthy and has no disease, insects, or harsh environmental conditions. Make sure to collect a representative tissue sampling. So how do we collect a representative sample? A representative sample is collected from random locations throughout the field. It includes 20 to 30 most recent mature trifoliate leaves. This area that is collected represents the average nutritional status of the plants that were collected. Quantity is important for two reasons. The laboratory needs enough material for the chemical procedures, and the sample needs to be representative of the conditions that are in the whole field. How do we properly collect petiole samples out in the field? The petioles need to be detached from the leaves that they are on. So you will snap the leaves off at the stem and then separate the blades from the petioles. This is to ensure that the nitrate reading is accurate. In conclusion, interpretation of a tissue report requires understanding several key factors that affect the results. Some key points to remember are properly label the growth stage, whether that is early, bloom, or fruit, for proper petiole interpretation. Also remember to label properly the week since first bloom for petiole interpretation to be accurate. Always be aware of the environmental conditions and how this could affect nutrient uptake and what kind of deficiency symptoms could occur. This concludes our presentation. If you have any questions, feel free to contact me at the email listed below, which is jessica.long@ncagr.gov. Thank you.